So thanks everyone for joining. My name is Nathan, as usual. I'm from the marketing manager at Data Science Dojo. And with me today is Joe Mayo. And Joe, if you want to go ahead and share your screen so that we can see that title page, that'd be great. Joe is an independent consultant and author, and will be giving away his cookbook today, his C# cookbook today. So um, and he's also going to be doing an introduction to C# language integrated query. And Joe, it's the acronym is LINQ, right? Am I saying it right?
That's
or
right.
Am I,
That's
okay,
right.
cool. So I don't look like a fool. So Joe, why don't you go ahead and get started? And then if you have questions today, if you're in Zoom with us, go ahead and use the Q&A tab like we usually do. Um, and Fatima, if you could repost the giveaway link, that'd be great. And then, yeah, so if you have questions, use the Q&A tab. If you're on our live stream, go ahead and ask your questions in the chat anyways, and we will make sure to pull them into Zoom to help us keep everything organized. So Joe, why don't you go ahead and take it away?
Okay, thank you. Nathan, so today I'm going to talk about language integrated query. And as Nathan mentioned, it's pronounced LINQ. And here's what I'm going to go over today. We're going to start with a background in declarative syntax. When you're programming, you've got different types of syntax. You have imperative and declarative. And I just want to highlight that as we go into the LINQ code so that you can see kind of like the approach that we're taking, what we're looking at there. Then we're going to talk about basic query syntax. So most of this webinar is going to be on, well, what is LINQ syntax? And so we're going to show you the basics here and how it's SQL-like and really super easy to read. Then we'll talk about some interesting things you can do with joining and grouping data because what you want to do with data is manipulate it in different ways and everything. And I'll show you how to do that. And then after that, just knowing the LINQ syntax is not enough. To put it into practice, you have to have some important concepts and tools. For example, there's something called materialization, because when a LINQ query starts, it doesn't execute until you materialize it. So we'll look at that. We'll look at providers, and providers are how you can get to a different data source, any type of data source, and the various tools and libraries that make up the LINQ ecosystem, if you want to see more about that. At the end, I'm going to have a question screen, and I have source code on there. And I believe that during the webinar, Data Science Dojo is going to post some of the links that I gave them on resources and everything, but the last slide will be there. And in my code repository, I also have this presentation. So let's start talking about declarative syntax. There are different ways to write code and everything, but a couple of the ways that you write code is either imperative or declarative. And the main difference between them is that imperative code is that you tell the program how to perform a task. You say, do this, then do this, then do this. It's very step by step. However, with declarative programming, it leans more towards the side where you tell the program what task you want to perform. You say, instead of saying how to do this, say, give me this. And what I'm going to do is I'm going to show you a few different language examples. We'll look at JavaScript and Python, and then I'll show you the same thing in C#. So let's look at some imperative code in JavaScript. And you can see at the top, there's a names array, and there's a non-Joe names. And as you might guess, I want to put all of the names from the names array into the non-Joe names array that do not end with the last name of Mayo. So if you look at this code, we've got a typical for loop, and it iterates. It's got a counter, and every time I go through the loop, I grab names out and put it in names, and then I have a condition on if to make sure that the last name is not Mayo before I put that in the non-Joe names array, and then I print each one out. And it's kind of interesting because you can see the for loop right there, and then you see me using for each down at the bottom. That for each is just a little bit more declarative than the for loop above it. So let's take this imperative code and rewrite it as declarative JavaScript code. And then you're going to see something a whole lot shorter. Notice that we're taking that names array and saying filter. That means I want everything out of that array except for the one whose last name is Mayo. And then I have a map. This map is really simple. It's an example, but I just want to show, well, I'm grabbing the whole object or the whole string out of that array. And then I'm printing that out. So you've got quite a difference between the imperative and the declarative, which says, give me this, not how to do it. Now let's look at a Python example. This is pretty similar. I've got a list. It's names, and I've got a non-Joe names empty list. And then I iterate again with an index I, grab that name, make that condition, and then add that non-Joe Mayo name to the array. And then I print it out. So that is the imperative in Python. Let's look at the declarative. Here again, we have a filter with a lambda that says, okay, give me only the ones without the last name Mayo. And then I do a map. And again, the map is simple, but that's a very declarative way to say, I want to get, well, the parts of this, if this was a customer object and everything, which you're going to see later, I'll grab parts of it and pull it back out of the filtered names. And then in Python, you need that stuff to be a list in your results before you can print it out. So that was JavaScript. This is Python. And now let's look at a C# example. And so this is a little bit longer because you've got a lot of curly braces in C# to say the beginning and ending of the algorithm and everything. But in basic terms, it's the same as the two examples, the JavaScript and Python you just said. It does everything step by step. Now let's look at the C# declarative example. And notice how my filter is where. And I've got a lambda that says, filter that out for all names not Mayo. And then the select is the map. And in C# terms, we call the where filter and the select projection. And what you're looking at right there is a form of LINQ. It's language integrated query, except that this is called method syntax. So everything I can do in a language, in integrated language, I can do with method syntax and LINQ in C#. So if I was an optometrist, I would say, which is clearer, imperative or declarative? And I hope that declarative is a compelling approach for you. And this is kind of like the approach that C# LINQ is taking by giving you something more declarative, where you tell the code what you want to get that data out. Because you see, you've got all kinds of data sources that you can read from, which I'm going to talk about later on. And those data sources could be a SQL database. They could be a CSV file. They could be JSON. They could be any API across the internet. If somebody's built a provider for it, you can get that data. In this example, I'm using this names array. Well, that's an in-memory data source. And the flavor of LINQ we're using in this demonstration, in this webinar, is called LINQ to objects, which is an in-memory data store, which is very useful because, as I'm going to show you later, when you pull in data from disparate data sources, you can join it and you can use the same syntax with it. So any questions about that? Imperative versus declarative syntax. Okay, so let's move on to the next section and talk about the basic query syntax. Now, you know this where and select that you just saw in declarative? If I flip over here and look on the right-hand side, you can see a from name and names and where the name does not end with Mayo and select. And this is very SQL-like, except that I've rearranged things a little bit because the syntax starts with the from instead of starting with the select. And I'll show you why. When we go to code, I'm going to have a code demo. And I'll show you what the benefit of that is. But this is essentially the same thing that I just told you, except for we have keywords in the language that are from and in and where and select and more. So let's go look at code. And over here, I have an example right here with this basic query syntax. Now you can see here that I have an array of names that we had before, and we're reading from that names. That's the data source. And there it's a little bit larger to see. And so we got the from first. And here's why putting that from first is important, because this is C# language. This is a programming language. And with programming languages, we have modern IDEs. And by saying we know what that collection is, we know what the contents type is. See how that's a string right there when I hover over it? If I go down here into the where, I can dot into it. And then I can get IntelliSense. Well, I'm not getting IntelliSense here because there we go. Okay, and you can see everything that's available on there, and which includes the ends with right there. So that's the reason why we put the from first instead of the select as you would normally see in SQL. But there's the where, and then if I hover over this, you get a name back. Now notice that this is a var. In C# that means it's strongly typed. I can assign something to it one time, but once I assign something to it, it's strongly typed. And if I hover over that, you can see that it's something called an IEnumerable string. And in C#, IEnumerable is something like an array or a list that I can iterate through. It's a collection of things. In this case, it's a collection of strings. But because sometimes, I'm going to show you later, sometimes you don't know exactly, you can do a custom projection of this, then I call that var, and I go none, then I go IEnumerable. So I've got a question here. The C# is applied to resolve machine learning models. Okay, so not necessarily, you know what, the language integrated query is a way to work with and manipulate data. So if you want to use machine learning models, then C# integrates with all kinds of third-party libraries that let you do that and everything. And there's like versions of TensorFlow, which we call the library, the binding to TensorFlow, TensorSharp, or PyTorch, and called PySharp or something like that. And Microsoft has a machine learning library called ML.NET. So you see, if you want to take your data and manipulate it and prepare it before you feed it to these models and do analysis and stuff, then you could potentially use LINQ, but it doesn't have ML built into it intrinsically. So that's this example, but let's go and look at some of the things you can do with LINQ beyond the basic example right there. Here I have projection. And if I open this, then here, instead of working with an array of strings, here I have something called a list. In C#, that list is a collection. It's an IEnumerable that you can use to iterate through customers or hold customers and so on. And let's go look what customer is right there. It's a C# record, and it has these properties right there. And here I might be simulating a situation where you're interested in analyzing a customer's last purchase SKU or last purchase amount for some purpose and everything. And what we're going to do with this projection is we're going to take these customers and we're going to reshape them into something that has name, SKU, and amount, because we don't need all of the things in the original data. We just need a subset of it. So this is how we're going to do it. I created this list of customers and populated it with data. And then I have this query. And again, I got here customers I'm iterating over. And for each customer, I'm reading from, I have this select statement, and my projection is to take the information off this customer. And for example, on the name, I combine first name and last name into a full name. And then I'm just putting the SKU and amount in there. So that gives me a different shape of the data. Now, sometimes my instantiation of my projection gets too busy. And so LINQ has this cool thing called a let clause. So between the from and select, I can give that a variable name and do some type of manipulation up here so that I'm not trying to do that all in the middle of my projection. Certainly I could, but now you have a choice whether you want any extra logic here or here. So that's a couple ways to do projections. And again, then just the for each to print those out. So that was a projection, which is kind of like the same as a map in JavaScript or Python. Now let's look at filtering. And my collection of customers is a little bit different this time. I put a couple items on here and notice that the top one has 64 cents and this one has $157.91, whereas the rest of these are somewhere between $13 to $20 dollars. And these, and let's pretend I did some analysis and said these are outliers, and I don't want those in my data results. So I'm going to filter those out. And here I have a where clause, and I'm going to say where the last purchase amount is between $5 and $20. So that's greater than, and I can say greater than or equal if I wanted to include it. I can put any operators there. Notice that my where clause can get arbitrarily complex because I have an and operator there. I can put or operators, and I can expand that even more by parenthesizing what I put in the where clause. And so my select is just a customer here. No changes because I just wanted to talk about how to do the filter. So you can do some sophisticated filtering in here to get the results that you want. So let me go ahead and run that. And I'm using the .NET command line here. I'm going to say .NET. And you can see that my filter only gave me these 3 records, not the outliers. So let's go to one more basic syntax example. We'll go to sorting. And in sorting, I want to sort by last name, and notice that the last names are not in order in the list. If I didn't sort, this is the order I get them out, the order that they're in. And here in my query, I say order by last name. And if I did this and said the and then I get these ordered in alphabetical order by last name. And you can also do something really cool here. You can order it by last name descending if I wanted to. And that would give me these values in reverse order right there. So this is all built into the language. So that was projection and sorting and filtering. And here is the slide. I include these slides with the downloadable source code on GitHub so that you can look at this if you want. And then the sorting example. Any questions about basic syntax? Okay,
Joe,
great.
Joe,
Yeah,
we have a question in the chat. If you can open that up.
in the chat. How far down is it?
I think it's the first most recent comment.
Can and also do mathematical equations when you restructure your return projections. You can, because when I go here and I do this projection, right here, right there. Notice how I'm doing this. I could have put a mathematical calculation in there and the amount, maybe I want to do something on there. Like say for instance, if I wanted to constrain these values to a certain range so that I could even out, normalize my data set and everything, then I can do that there. And I can actually do some cool stuff. Like I'm going to use this as a better example. If I had a method that I wrote and I said, I could call a method called normalize this amount right there. And if I wrote that, I could put all the math in it, or I could just write the math right here if it was kind of simple. So you can do that. Great. So yeah, that's possible. Okay, so on joining and grouping. Now let's say you have two disparate data sets and you have to combine them. You got them from different places and you have to figure out how to put them together. You can join them. And if you're working with data in memory, the join works really well. Another thing you can do is group, because sometimes you may have done analysis and said, okay, based upon these properties of this data set, I need to group these things and do aggregate analysis and everything. So you can do that. You can group, and I'm going to show you how to do it. Here's an example of kind of like a join, but let's go actually look at some code and see how that works. Okay, so in my example, I have a customers collection and a last orders collection. And this may look familiar because I took the customers collection from the last demo and just split it up into two. And here I've kind of like lined up my IDs. I made it easy on myself. In real life, you may want to try to correlate on like names or emails or something really difficult and everything. But so I did this. And so I've got numbers and last orders, and I want to join them together. And here I have a customer and I have a last order. So you can see the shape of what that is. And in my join, so I've got my customer, and now I've got last orders, and I need a range variable. Here's my customer, so my range variable for customers' orders, my range variable for last orders. And I'm going to say, okay, what do I want to join on? And in this case, I'm using the IDs of each. So that pulls those together. And when I do my projection, then I use whichever range variable applies to whatever data I need for customers, and this one for orders, and pull that together in the same object. Now I could have created a new record or class or whatever I want to do with C#, like I got customer and last order, that had all of this data in it. But I wanted to show you something else that was really super interesting, was that notice how in one of these other examples where I said new customer summary, I used the named type right there. But in this, I did not use a name type. I just said new, and I just created an object. That's called an anonymous type. And if I hover over that, it says new anonymous type. You know what? The compiler gives it some kind of name. I don't know what it is. We don't care, because one of the things you might want to do is say, okay, I want to join this, create this, and then in the same method or in the same algorithm, you want to do more manipulation on it. Well, it's just an intermediate value for that data that you're working with. So why create a new type when you're just working on intermediate data? So this is a convenience and everything, but it's also a reason why we have this var here, because now we know, because I'm projecting on an anonymous type, this can only hold anonymous types. So I don't know what the type is, so I can't put a type there. C# is strongly typed. And if I look at this, it's an enumerable, a collection of that anonymous type. So you've got these things that were built into the language just to support LINQ. But what's important here is how we do that join, how we can pull this data together and do that. Now let's go look at grouping. Again, if you want to do some group analysis or some hierarchical aggregation or reporting or something of this data, it's really convenient to get it into a group. And you'll notice in this example, I'm going to group on this SKU. And notice how I've duplicated it so that I know I've got multiple values in each group. And in my query, I'm going to group this customer by that value, the SKU, right there. And I'm going to group that into the customer group. So I'm going to give myself another variable on how to work with that. And when I do that, I get an object that has a key and a collection of the items that go in that group. And the key is group name, which comes from here. And so if I hover over that, you can see that it's an I grouping of string, which is the key, and customer, which is the object type that I'm querying. And I'm selecting that group. So that when I go down here, out of those groups, I take each group, I print that key, and then I print it out. But let me run this so that you can see what it's doing. There. And let me type .NET run. Silly me. Okay, so you can see these groups right here. And then these are just strings. Otherwise, you get all the other items on this group. So you can imagine how you might do the grouping. And then on each item of the group, you can do some type of aggregation of that data right there, or just have something that you can print out in a report or do some further manipulation. So that was grouping. Let me go back to the join so you can see the output of that. And that join, you can see those objects that I created. Okay, so it's printing out the entire object that we created there. So that is grouping and joining. And any questions on grouping and joining? How do you do having and LINQ? Okay, so having is kind of like you've got a query and then you do a having on what the result of that is. So in this case, I would do the query, and then on the result of that query, I'd do another query with a where on the results of that. How is the performance in large data sets? Well, I haven't measured it in large data sets and everything. And so imagine that this is all being done in memory. And this is LINQ. And so it's a provider that's optimized to give you that syntax for convenience. Now, If you've got a heavily performant requirement where performance on manipulating the data is very important, you may actually consider going back to a for loop. So that's where the benefit of the imperative approach would outweigh the declarative approach, because in this case, LINQ has a lot of internal provider mechanisms going on. And another caveat to that is that it depends on the provider too, because you've got certain providers that implement how to interpret the LINQ statements, and some may perform better than others. So the best approach is to say not that LINQ is fast or slow or make a blanket statement on it, is to try out your data set and your algorithms both ways to see where your performance goes. So I know that was a huge non-answer, but I think that's the best answer you can get, especially when you're talking about performance. And one more thing, I keep on thinking about one more thing. C# is a compiled language, whereas you have other languages like JavaScript or Python that are interpreted and everything. And so your performance difference may be quite significant because C# runs pretty fast as compiled code, especially once it's already compiled and in memory. Performance is really great. Okay, so that was joining a grouping. So here's some examples that I just showed you, just so that we can have a slide for that. So that was a lot of the basic syntax of LINQ and everything, and that'll get you far. But there's a whole lot more to it, because I was using the in-memory provider, and providers are called linked to whatever the provider name is. And so there's other providers out there. There's a built-in .NET provider called LINQ to XML, so you can query and build up XML data. LINQ to EF. When I say EF, I mean entity framework. And this is a object relational model that Microsoft has that allows you to connect to all kinds of different databases. For example, of course, SQL Server, Oracle, MySQL, and the list goes on. And other databases, they have their own entity framework providers, and there's third party, and there's open source on it and everything. And I put LINQ to Twitter in there, and I have to put in the caveat that I'm the one who wrote the LINQ to Twitter provider, and that is a LINQ provider for querying the Twitter API. And so really, any data, whatever, you can build a provider for it. And I'll give you a link on how to find some of those providers. But materialization is an important concept, because you saw the queries that I wrote. Well, you can sit there and you can write these queries and you can attach them to each other and build this whole processing session right there, but it doesn't execute until it, quote, materializes. And so I'm going to show you when a query is materialized and when it's not, so that you'll know. Also, in addition to the language integrated syntax, there's a whole standard library that Microsoft provides with a bunch of extensions that you're going to want to use. And in addition to the extensions that Microsoft provides, there's third-party providers for LINQ that's pretty useful. But I'll show you some of the standard operators that you can use so that you can understand what I'm talking about there. So we're gonna demo this. And I want to show you a few operators so that you can kind of like get a feeling for it. So you might remember if we were over here, we had, okay, we just had a query right there. This is setting up the query, but it does not execute until it gets materialized. And then once we put it in the for each loop, it materializes and runs. Here we have some operators that materialize a query. Right here, look how I took my query, and I like to line these things up and put my parentheses around it. So I put the parentheses around the query, and then I use this distinct so that I can get a distinct query on this. And then here I could say, I could just say like C first name right here, C dot first name, if that's all I wanted to do that with. But in this example, I also wanted to show you how to do like a composite key. And this is like when you're joining or grouping and you need a composite key, you can do it this way too. Remember the anonymous type I told you about a little bit ago? This is what this is. It's an anonymous type that I can use as a composite key. And these two keys determine uniqueness in that object right there. So it's a distinct. And once I've done that, then I use this toList, and that'll give me a list of customer. When I do toList, I know what the type is. So now instead of using var, I could have used var, but I only use var when I have to. When I know the type, I just say what it is. And then I said toList. So it takes this and returns a list of these to work with. And so for instance, if you're building a method that returns a list, then you'll want to materialize it this way. But in addition to toList, I'm going to say, I'm going to show you a few more of these with IntelliSense. And I'll say here, dot to, okay, to array, and you can do to dictionary, to hash set, and so on to get all of those out of there. And then I print those out. Here's another operator, a standard operator, it's called average. So in addition to average, you have min, max, sum, and so on. And there's also third-party libraries that give you all kinds of built-in operators for mathematical operations. And also you have set operations. So in this, I have distinct customers and I have potential customers. And so here's my customers and my potential customers, and they don't have SKUs or anything because they haven't bought anything. That's why they're potential. And I just want to pull all those together so that I can look at everything here and I can say union. But there's also extensions for except or intercept and so on. So you can do your logical operations on sets. And so there's a lot more than that. That was standard operators and everything. I just talked about materialization a minute ago. See how I materialize with that. When I do that, then it actually executes the query. Now, working with in-memory data sets may not be as important, and actually it is, because you see, you don't want, if you got this query and you want to take the results of that and do some more manipulation with LINQ on it and everything, you don't want the thing materializing until you're done and everything. So you can do these queries and then everything, and then materialize it when it's over with and everything. And here's some of the things you can call it. You can say toList, to array. You can get a count. You can say any, and instead of doing count, any says, well, are there any records in here that match this condition? So I would go in and do a where clause on something, and the any will stop after it finds the first record that matches that condition, as opposed to count, which will iterate through the entire collection. So, and then there's a for each, and that materializes also. So anything that causes that query to produce a result that you can use will materialize the query. And so we're talking about linked objects here, But this gets really important when you start talking about external data sources like databases and everything, because you don't want these queries running down the database back and forth, because you're going to the latency and the time to get back results while you're still putting together your query on the client is gonna like take more time than you need. So you only materialize it at the end when you want it to put this together and execute. And also, if you got a provider that's optimized, when you materialize, it's going to optimize your query instead of all these individual queries hitting your database and killing your performance. So here's a few standard operators. There's many more. I'm going to give you a link on the final slide on what's available in operators, and you can see. But here's kind of like a bite-sized look at the type of things that you can get out of here. So this is the end of my presentation. The source code is right there. My email address, my Twitter. There's the LINQ documentation right there. And there's also my link to Twitter provider. Let me show that to you really quick. Let me hop over here and look at. So over here, I've got the link up there, but this is on GitHub. And let's kind of like go up here. So when you're working with a provider, the in-memory provider I showed you was just a collection of objects. It's an enumerable. But you're going to get some type of a context that represents the provider right there. And so you set this up according to whatever their rules are, usually a connection string or credentials or something, and then you get that provider instance. And then the providers have some type of a property on them telling you what kind of data you're going to get back. In this case, it's a Twitter API search. And so I put in my conditions of what I want to get back. And then here's another standard operator for single or default. There's first or default or just first and stuff. So I know I'm getting a single response back. And in there, then I go through statuses and iterate and print out those things. But again, here I'm using this same convenient syntax for all of these different data sources that I can pull together. And I've got a single common way to work with data. And I don't have to learn all of the nuances about every data set that I ever had to work with for the rest of my life and everything. So that was linked to Twitter. It's open source. And here's my slides. So do we have any more questions?
Yeah, if you all have any questions, please post them in the Q&A chat, or if you're on a live stream, just post it in the chat. I am getting our submissions put together for the ebook giveaway, and then I'll announce the 3 winners.
Okay, cool. Let me show you this NuGet right there, nuget.org. So this is pretty useful because I get my header out of the way. Because this is a package manager for .NET. And if you go in here and type LINQ, and I've got like 52 packages, and they're not all LINQ providers. They're anybody tagged with the word LINQ. But here's Microsoft's library. And then if you go down this list and everything, you can see different providers in there. There's SQL-like provider. There's reactive extensions if you'd like reactive development. And then if somebody typed in like the keyword Twitter, then there's my provider right there. And there's much more there. Let me go see what else is on my list that might be interesting for you. There's my book. Please go out and look at that. And then the Microsoft LINQ documentation. And Microsoft has pretty extensive documentation. And they may even have more information on various providers. And they'll have all of the entity framework information if you want to use that to connect to any type of database. So here it is, getting started and everything. Really great documentation. So I got another question here. Can you join the data from two different sources, Twitter and SQL, for example? Yeah, that's what's great about the join. But here's how you would do it. You take your provider and go out and grab the Twitter data, and then you go out and use a provider to grab your SQL data. Now you're going to need some way to correlate those two records and everything. And so what if I had, let's say, for instance, I have this Twitter data that I was storing in my SQL server. Well, you can query the Twitter data for tweets and get that tweet ID, and then you can go to SQL and you can pull up the users that you've stored in your SQL database, and you can correlate on ID with the join, and you can do an in-memory join operation on that.
All right, I'm not seeing any other questions. So Joe, I'm gonna go ahead and announce the winners. And just a reminder, if you are a winner, I will share your contact information with Joe, and then he will share your information with his publisher so that you can get access to your ebook. So congratulations to Romana Hill, Stephanie Ireland, and Vanessa Sneed. I'll send you an email just to confirm that you won, and I'll include Joe's information there just in case you have questions for him. And Joe, I'll share their information with you so that they can claim their ebook. So congratulations to the three of you. And then Joe, thank you again for being here today. And thank you everyone if you joined. Tomorrow we will be, and I'm just getting the website pulled up, we'll be doing another webinar on time series analysis with the KNIME analytics platform. And we do have two KNIME data scientists, Corey and Merritt, who will be giving that presentation. So if you are available to join us tomorrow, 12 p.m. Pacific, same time as today, we'll be doing time series analysis with the KNIME analytics platform. So once again, Joe, thank you. We'll make sure to share all of those links with everyone when we put the webinar up on our tutorial site. For everybody else, this webinar is recorded. We will have it available with all of the links as well. So make sure to be on the lookout for that. Thank you, Joe. And big thanks to Fatima Rafiq, who also scheduled all of this. So thank you all, and I hope to see you all tomorrow.